Hello, my name is Balkis from Group 217. Together with my group mates, we will be presenting about the zero waste in oil and gas industry.
Hi, my name is Shri Natasha and I'll be presenting on introduction and problem statement. The oil and gas industry are considered as the largest sector in the world as it generates hundreds of billions of dollars every year. According to the 2019 Fortune Global 500 ranking, 5 oil and gas companies were in the top 10 of world biggest companies. This shows that the world is depending heavily on oil and gas industry. Malaysia has oil reserve of 3.6 billion barrels as of January 2020, which make it as the fourth largest reserve in Asia Pacific. Malaysia is also completing the country's first refinery that produces diesel and gasoline, which meets the Euro V standard. The presence of this refinery will help in lowering the emission levels of carbon dioxide. However, one of the challenges that oil and gas industry is facing is the waste production from the industry, as the waste materials produced is discharged directly from oil rigs into the ocean. There are high risks being posed to the environment and human health as the demand of petroleum keeps on increasing, which causes the operations of the industry to increase. Studies has found that there are limitations of waste management practices in Malaysia, and some of them includes lack of knowledge on petroleum waste management, lack of commitments from Petroleum Waste Management Party, and insufficient petroleum waste management technology. Therefore, the objective of this paper is to study the appropriate control system for a zero waste management in oil and gas industry, to identify the challenges of the process control system, and to provide recommendations for process control system improvement.
Hello, my name is Mohammad Nasrullah and I will be talking about the elaboration of control system involved in oil and gas industry. The increase of demand is beneficial to the economy, but it is sadly also harmful to the environment. Petroleum refineries release dangerous and poisonous gases such as nitrogen oxides, carbon monoxide, hydrogen sulfide, and sulfur dioxide. It was considered as one of the most significant contributors of air pollution. To prevent this from happening, a treatment method for SO2 gases called flue gas desulfurization was developed. FGD, in short, is a SO2 treatment method that involves contacting flue gas with limestone slurry or lime. But there is a downside of this procedure, which it requires a lot of water. Researchers looked into a strategy to solve the problem, and they discovered to employ CO as a catalyst for reduction of SO2 gas. For this SO2 reduction process, a mass controller is employed as a process controller. A mass controller can be analog or digital. It is designed to regulate a certain type of fluid over a wide variety of flow rates. The controller's tuning is PID since it can regulate temperature, flow, pressure, and speed. Also, because this controller uses closed-loop control feedback, and the goal of the system is to reduce the flow rate difference to zero, a PID controller is employed. PID controller is frequently utilized in industries because its combination provides a faster response time, low offset, and the ability to eliminate offset. It features a very fast analog and a very high speed. Furthermore, it is critical to use a PID controller for the treatment process so that the desired output can be achieved for emission to be safe for release to the environment.
My part will be the challenging concern of process control in oil and gas industry. Due to the huge fluctuations in differential pressure, control valves exhibit tuning and range difficulties. Secondly, the PID controller must react to the variable pressure differentials and variations in downstream pressure. Thus, it may affect the stability of the MFC flow rate. Thirdly, the PID controllers exhibit poor control performance when used in an integrated process with a long time delay. Next, integrator windup. This is when the controller surpasses the system activated saturation limits and is unable to react in real time to changes in the control error. Next, the derivative control quantifies need to apply more changes by linking the amount of change applied to the rate of change needed. Lastly, it is difficult to maintain control over the monitoring of set points and the rejection of disturbance in SO2 reduction efforts.
Hello everyone, I'm Samson Fugongji. I will be presenting on the recommendations for the improvement of PID controller in the flue gas desulfurization process. The first recommendation is to add a programmable logic controller or so-called PLC into the control system PLC is a ruggedized device that are commonly used in industrial automation, and it can be used to automate a specific process, run a machine function, or even the whole production line. These are some advantages and disadvantages of PLC. The first advantage is that PLC can start and stop all the processes automatically. Second, it can detect malfunctions in the system by generating alarms. Next, PLC can provide better documentation by producing runtime data, and this is very useful for the flue gas desulfurization control system. Lastly, PLC provides calligraphy and advisory system introduction to ease the operator interface. For its disadvantages, extra workload is needed on connecting wires. Second, it is only available in closed-loop architecture. Next, PLC has a limitation in performing under high temperature and vibration conditions. And lastly, extra training is required before using PLC. The second recommendation is to add a fuzzy logic controller, or also known as FLC, into the control system. Fuzzy logic control is an algorithm that instills knowledge and key element of human thinking in the design of a nonlinear controller. The advantages of FLC are that it is cheaper and capable to overcome a very wide range of operating conditions as compared to the conventional controller. The most important advantage of FLC is that it can emulate human deductive thinking in controlling system variables, where it can take the imprecise and distorted input data during the sulfur dioxide reduction and transform them into the logics that are useful and understandable. For the disadvantages of FLC, it requires a lot of data in designing to minimize the system error. Next, FLC is only useful with moderate historical data. Besides, FLC also requires high human expertise to improve the system accuracy. And lastly, a regular updating of rules is needed for FLC.
From the result and discussion part, we can conclude that PLC and FLC controller is the best recommendation to improve the control system in the flue gas desulfurization, because you can maintain a constant setting by predicting the future errors based on their rate of change. The previous system, which is the mass flow controller with the PID controller, did not manage to keep up large differential pressure swings, which could affect the SO2 reduction effort. In brief, both of these controllers will be able to resolve the problems identified and will have a minor drawbacks in comparison to the benefits they provided.